Just so we can get used to reading these coordinate pairs, let's name these points. So how about this? A. What ordered pair would this be? Well, look where we are. Start at the origin. To get to A, we're going to go 2 to the right and 4 up. Now, horizontal movement, that's going to be our first component, then a comma, and then the vertical movement, that's our second component. So what we're going to do here is we're first going to go to the right 2, then up 4. What about B? So to get to B, looks like we're going to go start at the origin, 1, 2, 3, 4 to the right and up 2. So this is going to go 4 to the right and up 2. So for problem 2, let's plot this point, negative 2, 5. So we're going to start at the origin. Right, let's move down here to the origin here. We're going to go to the left 2 and then vertically up 5, right, positive 5. So let's put a point there. To the left 2, up 5. There's our point. This is a good problem to show why graphing isn't always the best way to do things. It's not real accurate. Look what we want to do here. We want to plot this point, 3 halves, negative 5 1/2. This is 1 1/2. This is negative 2 1/2. So what we're going to do is we're going to start here at the origin. We're going to go 1 1/2. Now I picked a coordinate system that actually has that on there. But look, if I just had 1, 2, 3, I'd have to guess. So I got 1 1/2 and then down 2 1/2. So I just put a big point there, and you kind of have to guess that it's really right on 3 halves and negative 5 halves. So let's talk about quadrants here. If we have a coordinate system, we have 4 quadrants. We have this one here, right? The plane is infinite, and when we draw these vertical and horizontal lines, it divides the plane into 4 equal infinite spaces. This one, this one, this one, and this one. Now we're going to number these with Roman numerals, starting here, going counterclockwise. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Now let's draw it again and see what's going to happen here. In quadrant 1, if you pick any point in quadrant 1, how do you get there? Well, you move to the right, so positive, and you move up. So what we're going to get here is that these points here are going to be positive, positive, right? The x value will be positive because we move to the right from the origin, and the y value will be positive because we move up from the origin. Now, a point over here in quadrant 2. Well, we're moving to the left of the origin, so we're going to have a negative for the input and positive for the output. Let's move down here. Okay, we're moving to the left and down, so to the left, down, and then finally here, we're moving to the right and down. So in what quadrant is this point here? Well, it's negative 10, so we know we're going to the left, and it's up. So we're going to the left and up. So this point is going to be in quadrant 2. All right, let's try to read this one. What we want to know is in which quadrant is this point? And here's what we know. X is positive. So what we're going to get here is, let's draw a coordinate system. So we'll draw a coordinate system. Now, we're given that x is positive, so we know that x is over here someplace. And y, the vertical, is going to be the opposite of x. So if x is positive, let's write what we have. If x is positive, this is positive, and y is the opposite of x. Well, if x is positive, right, the opposite of x is going to be negative. And where are we here? So we're positive, so we're out this way, and negative, so we're down here. That's quadrant 4. So let's state now that we're going to be in quadrant 4. What we're going to try to do now is to graph this equation here. Now this is a line, and I know it's a line because the exponents on the x and y are both 1s. That's called a linear equation. And before we go any farther, let's just get a point across about lines. Now when we draw a line, we'll just start someplace, and then we just go like this, right? There's a line. You just start and you go. Now here's what this really is. If we were to magnify this, what this really is just a collection of points that happen to line up in some pattern. And every point, when we graph something in a coordinate system, is going to be like this. Okay, if we graph something, we're going to really get all these little points here. Now when you back off, right, and you look from a distance, they all blend together and you get a line. But what happens is this. If you pick any point, that has an x value and a y value. So there's an ordered pair there, a and b. And this a, when you put it into the function for x, this b, when you put it in the function for y, and compute, you get a true statement. Every one of these points on the graph is a solution to the equation. If it's on the graph, it solves the equation. If it solves the equation, it's on the graph. So let's get some points. Now, this is a line, so we really need only 2 points. Let's maybe try for 3, just to be sure that they line up. Here's a good one. What about if x is equal to 0? Let's choose some x values. Then we'll get y is equal to, what, 0 plus 5, which is 5. There's an ordered pair, 0, 5. Now, I don't want to get too close because it's hard if I get too close here. 1, 2, 3. Hard to draw that. So how about if we go out maybe 3? So in this case, we would get 3 plus 5, which is 8. So here's an ordered pair, 3, 8. And then what if we even went back 3? So y would be negative 3 plus 5, which would be 2. So here's another ordered pair, negative 3 and 2. So we've got 3 ordered pairs. Let's plot these and then we'll pass a line through them. So first up, we've got 0, 5. So that's going to be right here. Right, 0 and then up 5. No horizontal, but 5 vertical. Now let's get this one, 3, 8. So to the right 3, up 8. To the right 3, up 8 is right here. And then to the left 3, let's get this last one, to the left 3, up 2. So to the left 3, up 2. Sure enough, those look like they fall on a line. Now I'll do what I can to get a straight line through those points. It looks pretty decent. All right, so we've got that line graphed. So let's try this one here. Y equals 2x plus 2. So let's draw our little table here and choose some values. How about if x is 0, y is going to be 2 times 0 plus 2. 0 plus 2 is 2. So here's an ordered pair. 0, 2. If y is 3, we'll get 2 times 3 plus 2. That's 6 plus 2 is 8. So we'll get 3 and 8. Then let's even go backwards here. What about 2 times negative 3 plus 2? That's negative 6 plus 2 is a negative 4. So we'll get negative 3, negative 4. Let's get a coordinate system and plot these 3 points. See if we can get a line through those. How about that one? Okay, there we go. Let's move on to number 8. So let's see if we can get the graph of this one here. So let's set up our little table here. Table of values, x and y. Let's choose x to be 0. We'll get negative 4 times 0 plus 5. That's 0 plus 5, so that's 5. Gives us this ordered pair, 0, 5. Let's go out to 3 again. So we'll get negative 4 times 3 plus 5. Negative 12 plus 5 is 7. So that'll give us 3 and 7. And then how about negative 3? Well, this will give us negative 4. Let's get that. Negative 4 times negative 3 plus 5 is, okay, that's going to be 12 plus 5. That's 17. That's going to be off of our coordinate system. Let's see what we can do here, though. So negative 3, 17. What if we just went, say, 1 to the right? So that'll be 4 times 1 plus 5. Negative 4 plus 5 is 1. So 1 and 1. We should be able to get that plot. So let's set up a table, x and y, and we'll get us 3 points. How about if we choose x to be 0? This will give us negative 4 times 0 plus 5 is 0 plus 5 is 5. So here's an ordered pair, 0, 5. Let's plot that. 0, 5, right here. get another one. Maybe we'll go out 3. So we'll get negative 4 times 3 plus 5. Now this is negative 12 plus 5, which is negative 7. So this will give us 3 and negative 7. Let's plot that one. So to the right 3, down 7. Okay, that puts us down here. Let's get one more. Maybe what we can do is get one more that's maybe kind of in here someplace, or even out here. Let's see, what if we tried negative 2? See what happens. Let's just go back here and kind of, I think will put us up here maybe. Let's try it. So if we try negative 2, we'll get at negative 4 times negative 2 plus 5. Well, that's 8 plus 5, that's 13. Now that's okay, but it's going to be off our coordinate system, so we're not going to be able to graph that. So let's try another one. Let's try 1. We'll get us something in this range right here. So if we try 1, that'll give us negative 4 times 1 plus 5. That's negative 4 plus 5, which is 1. We get this ordered pair, 1 and 1. Let's plot that one. Over 1, up 1. Looks like they could lie on a line, so let's see what we can do. See if we can pass a line through these points here. Looks pretty good. And there's our graph. All right, let's see what happens here in number 9. So let's set up a table. How about if we try x and y? Now, first of all, what we might do here is, what if we use x to be 0? And what we're going to get is 8 minus 0 over 4. That'll be 8 over 4, which is 2. So we get this ordered pair, 0, 2. Now, I notice this, that 8 minus 8 is 0. 0 divided by any number is 0. So why don't we try an 8 here? We don't have to try, just 0, 1, 2, 3. We can try any numbers we like. 8 seems to be a nice number, and it'll give us this. 8 minus 8 over 4 is 0 over 4, which is 0, and that gives us this point, 8 and 0. Now here's another point that might work well. What if we put in a 4? 8 minus 4 is 4. 4 over 4 is 1. Let's try that. So if we choose 4, we'll get 8 minus 4 over 4. 4 over 4, which is 1. That'll give us this point, 4 and 1. Let's plot these points. So first of all, let's go with the 0, 2. So 0 horizontal, 2 on the vertical. Then we'll go to the 8 and 0. So way out to the right and 0. 8 horizontal, 0 vertical, and then a 4 and a 1. So over 4, up 1. Looks like a straight line. Pass a line through these points. I think we're looking like this. There we go. Now, this equation right here, this function represents a quadratic. This is first degree, this is second degree, so this is not a line. This is going to be a parabola. When you have something to the second degree and the first degree like this, you get a parabola. Let's plot some points here. So let's start here by choosing 0. So we'll get 3 times 0 squared, which is going to be 0. Let's maybe try 1 and 2, and then negative 1, negative 2. See where that takes us. So this would be 3 times 1 squared, which is going to be 3. 3 times 2 squared. 2 squared is 4 times 3 is 12. That might be off our coordinate system. 3 times negative 1 squared. Negative 1 squared is 1 times 3 is 3. 3 times negative 2 squared. Negative 2 squared is 4 times 3 is 12. So let's plot these points. So first of all, let's go with 0, 0. So we'll plot 0, 0. That's right here at the origin. And then we'll come over to 1, 3. So to the right 1, up 3. That puts us here. And then to the right 2, up 12. All right, so that's going to be off our coordinate system. It's probably going to be up here. And then we'll go to negative 1 and 3. All right, negative 1 and 3 over here. Negative 2 and 12, so we're up here again. Boy, this is really tight. But what we'll do is try our best to draw a smooth curve through here with a rounded bottom, not a point. So that's called a parabola. And the bottom, this part right here, goes like this, right? It is not this. It's not a V. Now let's graph this function, and notice first that it is quadratic, right? We have an x squared term, so we're going to get a parabola here. And notice this, that the x squared term is negative, so the parabola is going to open downward. If you had a plus x squared, the parabola would open upward, but a negative x squared, the parabola is going to open downward. So let's build a table of values. We'll have x and y. And why don't we start here with 0? So we'll get 9 times 0 minus 0 squared. That's still going to be 0, so this goes right through the origin. Now, at 1, we're going to get 9 times 1 minus 1 squared, which is 9 minus 1, which is going to give us an 8. Now, I went ahead and filled some of these in, as you can see. I did 0, 1, 2, 3, and then negative 1, 2, and 3. And then what I see here is that it goes through the origin, and then it's up at 8, then it's up at 14, up at 18, and then on the negative side, it goes down very quickly. So why don't we just try to graph what we have to plot these points. So most of these points you can see are not going to be on our coordinate system, but we can get some. 0, 0 is here, 1 and 8 is up here, and then 2 and 14, well, that's going to be up here someplace. And then 3 and 18, that's going to be up here even higher. And then if we go on the negative side, negative 1 on the left will be at negative 10. So it looks like this parabola is moving like this. So why don't we get a few more positive numbers over here and have it turn around so we can see where it comes down over here. So I'll continue our table up here. And let's put in maybe 4, 5, 6, 7. Just see where that takes us. Maybe even an 8. See where that takes us. So at 4, we're going to get 9 times 4 minus 4 squared. Now that's 36 minus 16, that's going to be a 20. That's still off our graph. So at 5, now I put some of these in. At 5, I got 20 again. At 6, I got 18. Looks like it's coming back down. At 7, 14. At 8, I'm at 8. And then when I put in 9, we get 9 times 9 minus 9 squared. That's 81. Minus 81 is 0. So let's plot these points. Well, let's try to get some of these points here. So these here, these are just off the graph, so let's not bother with those. Let's go with the 8 and the 8. So let's plot that. So to the right 8, up 8. And then at 9, we're at 0 again. All right, so this is going to be a little difficult to draw, at least for me. It's going to go like this, right? And then it's off the graph up here. It looks like it's going to turn around, and then it'll come back through these points here. Well, that's a pretty shaky graph, but that's the idea. Now in this problem, the spring is stretched x inches by some force, F. You know, what we've got here is, let's do this. Let's get a picture of what's going on here. Here's a spring. There it is at rest. Now, if we apply a force to it, right, apply a force, like pull it down like this, put a weight on here. If we put a weight on there, what's going to happen is this spring is going to get stretched. So here's where it was at rest, and then if we put the weight, it's going to get stretched this far, x inches. Now what we know right here is that if we apply a force of 36 pounds, it gets stretched 9 inches. So the F here is 36, and the X here is 9. Let's put those numbers in. So we will get, here's our equation. F equals Kx. So we'll get 36 is equal to K times 9. We can divide by 9 to get K. So we will get K is equal to 4, and that gives us this equation here. F equals 4x. And what we want to do now is plot the graph of this function. So we can just make a little table. I'll do it right up here. Here's x and y. Now when x is 0, actually our y is what? F. We'll get 4 times 0, which is 0, so the curve goes right through the origin. At 1, to stretch it 1 inches, the f is going to be 4 times 1, which is 4. So to stretch this spring 1 inch, we need 4 pounds of force. At 2, we'll get 4 times 2 is 8. At 3, we'll get 4 times 3 is 12. Let's see what we have as our plot so far. So our first point is 0, 0, so that's right here at the origin. And then we'll go this point here, over 1, to the right 1, up 4. So to the right 1, up 4. The next point, right here, to the right 2, up 8. To the right 2, up 8. Now, do you see that this is going to be a straight line? Look at our function. First power, first power. This is linear. It's going to be a straight line. We've already got 3 points here. I'm going to plot this. I'm going to start here and just run it up this way. And, you know, I'm thinking that this line just starts here at 0. Now, what does it mean if you go here to the left? That means, right, this x is the amount, right? X is the amount we're stretching this spring. Now, I guess if we had negative x values, we're compressing the spring. So I guess maybe we could just continue this on down. Problem number 13 says that the formula relating scale A and scale B. Now, scale A and scale B, they're just making this stuff up in the book. So there's no real situation going on. It was just some scale A, some scale B, and they give us some equation that relates A and B. It says, if you know A, multiply it by 7, divide by 3, add 32, and you'll get B. So let's plot the graph. So again, let's make up a little table. Let's put in A, we'll get out B, and the values we're going to choose are these. 0 is always a good one, because if you put in 0, we'll get 7/3 times 0. It's easy to compute with. Plus 32, we'll get 32. Now, here's what I'm going to put in for B. For A again. I'm not going to put in a 1 because then I'll get 7/3 times 1, I'll get fractions. I'm going to put in for A some number that will cancel with the 3's. Like I could put in 3, they'd cancel. I could put in 6. 3 into 6 is twice. I could put in 9. 3 into 9 is 3. So let's try that. So let's put in 3. That'll give us 7/3 times 3 plus 32. The 3's cancel, and we get 7 plus 32 is 39. Now, let's actually put in a negative 3. So at 7/3 times negative 3 plus 32, 3 into negative 3 is negative 1. 7 times negative 1 is negative 7. Negative 7 plus 32 is 25. Now, I think we have enough, because A and B, if you look up here, these exponents are 1s. That means it's linear. It's a straight line. We've got 3 points. We just have to plot these. Now, these numbers are a little bit big, so it's not going to work on this coordinate system over here. Let's draw some coordinate system. May not be real accurate, but at least we'll get an idea of what it looks like. All right, so here's B, here's A, and at 0, we're at 32. Now, at 0, here's the origin. I'm just going to put a 32 here someplace. Maybe that's 32. And then if I go to the right 3, then we're up at 39. All right, so we're up at 39. So that's going to be a little bit higher than the 32. And then if I go to the right 3, we're at 25. Now I'm going to go up to 25. That's going to be a little lower than the 32. And I know they're on a straight line. So now I've got 3 points. I'm going to pass a line through them. And the graph, I know, looks something like that. Now, seriously, if I needed really more accuracy, I'll use some technology. I'll get a graphing program on my computer or get my TI-84 calculator and just graph it using that. So in our last problem that we're going to do here, we want to graph this function, h equals 1300t minus 4.9t squared. Now notice we've got a t squared, and these are first degree, so this is a quadratic. And the quadratic term is negative, so we do know this. We do know that the curve is going to open downward. Now here's what these letters are. This is the height of a rocket. h is going to be the height of a rocket, and t, this is the time since that rocket was launched. So let's make a little table here and see what we have. So I'll write t and h, right? T is the input, the independent variable, so we'll input that, and h is what we get out. So let's see, let's try a time 0, right just as we press the launch button. At time 0, now if you put 0 in here and in here, the whole thing's going to be 0, and that makes sense because at time 0, what's the height of the rocket? It's 0. It hasn't gone anywhere yet. Now what about after 1 second? Well, this is going to be 1300 times 1 minus 4.9 times 1 squared. So I've got my calculator out, and I put in 1. I got 1295.1. When I put in 2 seconds have gone by, I'm getting 2580.4. After 3 seconds, it's 3855.9. After 4 seconds, it's at 5121.6. After 5 seconds, put in a 5 here, I got 6377.5. Now, this is a parabola. It's supposed to turn around. So it's going up. We can see it's going up. It's got to hit some maximum height here, and then it's got to turn around. We just don't know exactly when that maximum height is if we keep doing this. But we can use this idea here. In a parabola, the vertex, the x value of the vertex is given by this formula right here. X is equal to negative b over 2a, where you have something like this. Here's what we have. You have y equals ax squared plus bx plus c. So a is the coefficient of the squared term, b is the coefficient of that linear term. Now, if we write our equation this way, we're going to have h equals negative 4.9 t squared plus 1300t plus 0. All right? The a in this case is negative 4.9. The b is the 1300, and there is no c here, so it must be a 0. And once again, with my calculator, here's what I got. I computed that. I got 132.65. Now, I put it in like this. I put in negative 1300 divide by, now, because I have a multiplication here, I need a parentheses. I put in 2 times negative 4.9. That gave me this number here. I did not do this. Negative 1300 divided by 2 times negative 4.9. What that does, it does the division first, then it does the multiplication. All right, so what I'm going to do is, I know that when I look at my graph here, if I come out to 132, about 132, this rocket is way up here and turning around. And at 0, it's at 0. So I know it looks something like this. And then if I put that 132, right, if I do this, t and h, if I put in that 132.65, when I put that in, I got 86,224, 86,224.